All right, let's jump right into this. Welcome to This Explainer. Today, we're tackling what is arguably the absolute ultimate cosmic mystery, and we're drawing from some really incredible source material about the search for extraterrestrial life. We're going to explore the universe, we'll look at the raw data, dive into the biggest scientific theories, and really try to wrap our heads around the sheer, almost unimaginable scale of the cosmos. I mean, our galaxy alone is so massive that it kind of forces you to reevaluate our place in it. So get ready to have your mind expanded as we systematically investigate one of the most profound questions humanity has ever asked. Picture this. It's 1950, and physicist Enrico Fermi is looking up at the billions of stars in the Milky Way. He realizes that our Earth is just this tiny, insignificant blue dot by comparison, and he asks a really staggering but wonderfully simple question. The universe has billions of planets, so where is everybody? This idea right here, known as the Fermi Paradox, is the beating heart of our exploration today. Because when you truly grasp the mathematical probability that other worlds exist, the absolute dead quiet we hear in return, it becomes this incredibly heavy, almost eerie puzzle that we just have to solve.
Section 1. The Great Cosmic Mystery.
Billions. Thanks to modern observatories, like the Kepler Space Telescope, we now know there are likely more planets than there are stars in our galaxy alone. Just think about that for a second. Pretty much every single star you look up and see in the night sky likely hosts an entire solar system of its own. As you mentally pan across the cosmos, the immense scale of it all is literally impossible to fully comprehend. Statistically speaking, given the age and the immense size of the universe, our galactic neighborhood should be absolutely crowded with life.
Section 2. Searching for alien signals. Now, humanity isn't just sitting around passively waiting for ET to knock on our door. We are actively on the hunt. First off, we're employing giant radio telescopes. We're basically pointing these massive terrestrial ears toward deep space, hoping to catch any sort of unnatural signal. Second, we generate these highly detailed star maps so we can pinpoint the highest probability targets. We're usually talking about Earth-like exoplanets sitting right in the habitable zones of their stars. And third, we rigorously analyze all that deep space data. We're running complex algorithms that scan for literally anything that stands out from the natural background static of the universe. And the tools we're using for this search, they are evolving so fast. Traditionally, we've relied pretty heavily on capturing radio wave data from deep space. Essentially, we were just listening for a deliberate broadcast, or maybe the accidental leakage of alien radio and television waves. But today, with cutting-edge observatories like the James Webb Space Telescope, it's a whole new ballgame. Astronomers can actually scan distant planets right as they pass in front of their host star. So what exactly are we hoping to find out there? Well, we're searching for massive technological footprints. In the scientific community, they call these technosignatures. Think of, advanced civilizations building towering, futuristic cities, or launching highly advanced spacecraft across their solar systems, or even constructing these mind-boggling megastructures, like a Dyson sphere, just to harness the entire energy output of their host star. Finding evidence of engineering on a planetary or stellar scale like that would, for sure, instantly change the course of human history. Section 3. Explaining the Great Silence. Okay, so with all this amazing technology, why the deafening silence? Why the crickets? Well, scientists have developed a few prime suspects. We've got the Great Filter, the Rare Earth hypothesis, the harsh reality of vast cosmic distances, and the very real possibility that, well, we just haven't searched long enough. Keep in mind, these are proposed scientific hypotheses that try to explain the data we have right now. They aren't confirmed facts, but let's break down each of these possibilities so we can try to understand why our skies remain so completely quiet.
First up is perhaps the most chilling explanation on the list, the Great Filter. This is a theoretical evolutionary threshold, or you could call it a catastrophic hurdle, that basically prevents most life from ever advancing to an interstellar stage. The idea here is that while life might spark up all the time across the galaxy, some sort of inescapable obstacle almost always wipes those civilizations out before they can actually reach the stars. That filter could be anything. It could be the immense biological difficulty of jumping from single-celled to complex life, or, more terrifyingly, the self-inflicted devastation of nuclear destruction or unchecked climate collapse. Now, an entirely different way of looking at it is the rare Earth hypothesis. Instead of assuming intelligent civilizations are out there destroying themselves, this theory suggests that the specific planetary and galactic conditions you actually need to support complex life are just incredibly, unbelievably uncommon. It requires a perfect cosmic cocktail. You need the exact right type of star, you need a protective gas giant like Jupiter to clear out asteroids, a stabilizing moon, active plate tectonics, the whole shebang.
So Earth might not just be your average rocky planet. It might be a wildly improbable cosmic fluke. We might have just won the ultimate galactic lottery. But we also have to face some pretty harsh practical limits here. First is just the sheer scale of vast cosmic distances. The space between star systems is so overwhelmingly immense that even if you were traveling at the speed of light, it would take years just to reach our closest neighbor. A civilization could be absolutely thriving out there right now, but their signals won't even reach us for millennia. And second, we have to look at our incredibly short timeline of searching. In the grand, billions of years timeline of the cosmos, humanity just turned on its radio receivers a fraction of a millisecond ago. We've barely even opened our eyes. Section 4. Are we truly alone? Ultimately, we are dealing with an observable universe of a measurable scale. When you look at the raw data and you visually travel through these colorful nebula and you pass by incredibly dense star clusters and you witness massive spiral galaxies that contain hundreds of billions of stars all on their own, and then you zoom all the way back to our tiny solar system, it is profoundly humbling. The immensity of the space we're trying to search is almost beyond human comprehension. It's like this vast, endless ocean, and we have literally only just dipped a single cup into the water. So, picture our Earth, just slowly rotating in the deep, quiet darkness of space, with stars stretching endlessly into the distance. It forces us all to ask, are we alone, or have we just begun looking? The great silence we're hearing right now might just be a reminder of how incredibly vast the universe is, and how entirely new we are to exploring it. There is just so much more out there waiting to be discovered. Thank you so much for joining me for this explainer. Keep your eyes on the stars, and never stop wondering.